for us is those two directions. Either you can take a form of a verb and end up with a morphological analysis of the 5 features present in that form, or you can give in to the transducer the 5 features and get out a verb form. So in this particular example we have here, we have the verb putarnachni, and if you feed that into the transducer will be able to spit out first, this is some form of the word nohi, which is our lemma, our like sort of canonical form in Han. That's a verb as in the brackets V. In the next brackets, we have TV, transitive verb. It's a perfective conjugation of that. But moving one further, it is a subject that is first plural, and finally it is an object that is. Likewise, if I were to take that string of tags and feed that into the transducer, it would be able to spit back out the form. So it can go either direction. There's some reason to think that a transducer that's finite state like this is somewhat better for the type data than a machine learning approach. But regardless, we wouldn't have enough data for a machine learning approach anyways, so this is what we're working with, and it seems to be working pretty well so far. However, working with a Dene language, there are some challenges. So we're going to talk specifically about 5 challenges in the process of fitting a Dene language into this system in our process so far. First, the issue that most Dene languages are primarily, if not entirely, prefixational in their morphology. The traditional approach to handling this type of transducer is to use a language called LexC, which uses continuation lexicons and by default orders the morphemes in the word and the tags in that sort of bracket version of the analysis in the same order. So for instance, if you have a Turkic language, Kyrgyz, that's over on the side here, you have to word the wing, followed by the plural, followed by the possessive, followed by the ablative, and the tags in the last line are in exactly the same order, and that's very tags. Like, here's the word, and then here's a bunch of things that are that's conjugation. Han, which is a prefixational language, would go in sort of a less obvious order if we were just to put tags in the same order that the actual prefixes come. So for instance, if we looked at putarnachni, we would end up with what's the object, then what's the subject, then what's the verb, then it is a verb, and then it's a transitive verb, and then it's an affect. So it's not the most logical ordering of tags, and it's certainly not the way that things are standardly done. So how people have gotten prefixes to show up in a good tag order before is more complex systems out of LexC, either using flag diacritics or more intricate continuation lexicons or simplified morphology. Lots of different approaches that can get you to a nice answer and getting the tags showing up in the right order, but ends up in more complex code that can end up in a bigger user size, which can lead to things like slower compilation or slower runtimes. So what we've adopted instead is an updated version of this formalism, which is called LexD, following LexC, which is designed for non-suffixational morphology. And instead of having continuation lexicons, it uses patterns, as we see in the gray box down the bottom of this screen. So instead of just saying, once you hit this morpheme, go to this, etc., you have a series of lexicons that you're pulling from, and the order in which those show up in tags doesn't necessarily have to be the same. In terms of matching to the verbal template we have here, all of these reference in the gray box that line up exactly with the specific slots that are in the verbal or template morphology. So if you look at the chart that we have, the verb is broken up. The stem is the final piece, and we have a portion in a reference in the list of patterns there that is also that same blue color for verb stem. And then moving backward, we have things like the conjugation marker, the theme, other the spacing's gotten all funky in the process here, but we have additional slots going backwards and pattern on each of those would be a label with its own lexicon that we can pull from at the time of our choosing. It might be notable to some people that when we are reading from this gray box at the bottom, there are 5 different parts that say verb stem, and there are 3 different parts that say subject, and several different parts that say object. And that is because this language has quite a bit of distributed morphology, where we have different features on it showing up, same speed feature showing up in different slots in the verb multiple times, which is our second challenge.
So as Maura was saying, there's a lot of distributed morphology in this language. So the stems themselves have, right now we've limited 5 to them. And so the lexicons are split into format. as you can see in the bottom chart, there's prefixes that go around parts of the word. So they're spread out throughout the word. And also this is the same for the subject markings as well. The pieces of the subject marking are spread out throughout the word. And so we had to account for that in our lexicons. And then also an issue we encountered was with the verb and subjects themselves. There's a lot of features, and these alternate in often an unpredictable way. So for stems, there's a common alteration based on aspect, the most common being like imperfective versus perfective. There's also future. All these different aspects can have different stems for the verb, and they can also alternate on singular or plural subject as well. These weren't very predictable or not as able to be treated as phonology. And also, here's an example of the subject variation. This is one of our 4 classifiers for the subject markings and broken out by aspect. As you can see, there's a lot of different forms that we all had to incorporate into our transducer. And then how we pull this all together, we used filter tags, which is a feature of LexD, to match the verb entries to subject markers. There's a lot of combinations. There's about 173 entries in the subject lexicon to account for all of these different combinations. And so each morpheme in the subject lexicon has a set of filters like this, and each morpheme in the verb lexicon has a set of filters like this, which are then matched together from the different lexicons to have those different parts that all go into a pattern that we saw earlier. Another issue we ran into was a lot of spelling variation. The spelling is not perfectly consistent across all of our sources. It's a pretty recent orthography developed, and not all the speakers are perfectly comfortable writing the orthography. To account for the spelling, we use the tag dirlr which we put onto in the transducer. So this made it so that if you put in for analysis, it would still be able to analyze the altered spelling, but it wouldn't generate those whenever you ask for a specific form. Also, similarly, we hit onto a lot of encoding variation. Has a lot of diacritics that have to be put perfectly into the transducer in order to be read. Otherwise, it counts different morphemes and they're not going to be analyzed. So as you can see, like with this A, there's a lot of different parts to it, and read in different ways or typed out in different ways. So our solution is we use Starlax rules, which they have a special syntax and they allow for consolidating different ways of writing the same characters into one, so they're not treated as letters. And so, as you can see, this is an example where the I and the agonic are treated as the same as the combined I with an agonic. And also, the ordering of the diacritics wouldn't matter either. Lastly, the challenge we looked at was tone spreading of one. It's quite prevalent with low tone spreading to the next syllable. Unless spreading creates a series of 3 low tones. This has some rules. It skips over schwas. It usually crosses word boundaries still, and they're always written. And the way we got messed up with the formatting. Hopefully you can see this bottom one. This is a Starlax rule that we implemented for that. The issue with tone spreading was that FSTs operate at the word level, so we had to account for going across the word boundary. And so we did this with the Starlax rule, where we allowed the first syllable of a word to be analyzed the same with a low tone or without a low tone. This isn't the perfect solution for now, but it did pretty well because it allowed both of those, like that spreaded tone, to be treated the same as one that without spreading. And back to morphological, I guess.
Right, so one exciting thing that this machine can also do for us is that it can take a stab at forms that it has not seen before. So even though the bulk of what we've done with it so far is to feed in forms that we know the answer in terms of what their analysis should be and got that analysis back, or vice versa, it can also deal with verbs that it hasn't seen before. So we, for instance, put in this verb that is the middle of the screen, shinate, and it means you are all barking at me, talking to your dogs, which is a large part of the culture up in Alaska. It's having a lot of sled dogs. So the transducer can take this form and take a stab at what it thinks the morphology is going on in here. For instance, it can see that there is sh at the beginning, which is always going to be first person singular object marker. So all 4 guesses that it comes out with are first person singular object markers. But after that, it gets a little bit more unsure about what to do. So it tells us that we might have a third singular subject or a second plural subject. It tells us we might have a 0 classifier or a D classifier or a bar L classifier. But importantly, it gives us all of our options, including one that is the right. The downside of this is that there is a fair amount of over-guessing in its sort of base form of the guesser, mostly because there is a single null morpheme that shows up for a very rare case of third-person singular subject marking. So this will over-guess and say, anytime we have any word, there could be that null morpheme at the beginning, and maybe the rest of the word is all the stem. The entirety of the word is just the root, regardless of how long it is, and even though that would be rather unlikely. Or four syllables in this language. However, we are trying to narrow that down by doing things like saying we don't actually see any roots that start with things like vowels or a certain consonant cluster. If we start narrowing that down, we can control how many times it's taking that sort of false guess to the null morpheme that isn't really something that we see all that often. So we're getting fewer incorrect guesses with that, and we are getting more and more towards it predicting the right answer for pulling out specific morphemes and roots.
So if we take a look at what's actually in our transducer, right now we have a small lexicon, and it covers a lot of common words in our test corpus, like stories we were looking at. There's a lot of nouns in there. We have some verbs and a lot of alternate spellings based on those alternations that we talked about earlier. The columns, unique versus total. So this is the count of like unique forms that we have, and then the total. The unique excludes spelling variants and also context open-ended stems that alternate. As you can see, for the most part, it's roughly equal, but the verbs have a lot of alternate alternations, so that number is a bit different. Our corpora, we looked at the short stories that we talked about. These were manually transcribed, and then we also looked at the elicited sentences in those verb paradigms. Beneath all those charts, there's elicited sentences. And those sentences in Han were extracted using a script with pattern matching, and then manually filtered out from like English and other various comments that were extraneous. If we look at how the transducer actually did on these corpora, we were evaluating naive coverage and like naive coverage, which is just the raw percentage of tokens. We were just looking at how much it actually got rather than the accuracy itself. So you can see the stories did pretty decently, around 60%, and the elicited sentences were substantially lower, but still a good amount. The stories corpus has a lot higher coverage. It has a lot of uninflected parts of speech in it, like more easy speech, easier to catch by the transducer. The elicited sentences have a very full range of verbs. You know, these are trying to get all these forms out for documentation purposes, and there's lots of forms that we didn't account for in the transducer. There's also dialect variation in the elicited sentences, which we haven't yet implemented our transducer. But it is a good sign that the data we based off our transducer off of is being analyzed by the transducer. So to improve this coverage, we're going to look at more verbs, more style relax rules, and more phonology. Lastly, to conclude this section, we feel like this Alexia approach was pretty solid. It was a lot faster and smaller approaches. And there are some stats that you can look at another time.
And then the final thing we want to say is just what are we going to do next, and what is the point of doing any of this in the first place? Try and build out more words and more morphemes, more phonology into this whole thing, but I'm going to skip over that concept in the interest of time and just say that one is to build in the dialectal variation between the two dialects, have systematic vocabulary and spelling differences. So that's a big goal for us as well. Largely because our main goal for doing this project is the revitalization aspects of it. How can this be used in ways that learners? And one is that it can be used as a verb form generator, where you give a website a verb form, who's doing it, when they're doing it. and it will spit out a form for you in a more user-friendly way than just all those tags and angled brackets. You can also take that same sort of mechanism and make a paradigm generator, which will tell someone all of the forms of a specific verb. And finally, you can also do sentence level, a little bit more work built into the system, but there are several built already off of the same base program, where we can give people an actual sentence by sentence translation for words in Han, which is great because they're kind of spread out and not all of them have access regularly to a speaker of the language. So what we've done here is that we created a LexD based that is hopefully more efficient and useful to us then to create these materials that will be able to be an efficient type of efficient type of revitalization material that language learners can use in the process of learning, be able to access online, very quick, very easy to get data for the language they are trying to learn. Good. Thank you so much. I'll say also that person who's on the screen is Jonathan Washington, who's also a co-author of ours, and any technical questions.